Hey Prashant, good evening.
Hi Rishabh, how are you?
Good, good. How are you?
I'm fine.
Yeah, are you aware about others? Are they joining?
Yeah, I think so. We can wait for them.
Sure.
Actually, you are also late. Like 5-10 minutes, you are also late.
No, man, actually, I was waiting for the host. I've joined around 8:59, but I think they forgot to prove.
Ah, it's okay.
Yeah,
Like we can wait for them like 5-10 minutes.
sure.
The last class there were like around 7 people, right?
Yeah, yeah,
Yeah, we can wait for them. It's
sure.
okay.
Yeah, meanwhile, you guys can tell me about the homework that I've given. Did you attempt it? Prashant, Rakesh? Okay, then we can start our session. Good evening, all of you. Okay, so we last in the last session we discussed about right all the statistical methods, what is statistic is, how we use it in our real life, right? How is it important for the data science, correct? So today we will learn it in little detail, right? So quick recap, right? We learned about right how statistics helps, right? It helps us in collecting, organizing, analyzing, interpreting, and presenting the data set, right? We also discussed about the type of statistics, right? One is descriptive and another one is inferential statistics. And we even discussed about the variables, right? The type of data, nominal, ordinal, you know, interval and ratio. And the two broad categories that were categorical and numerical. Remember? Prashant, Rakesh, yes or no? Hey, am I audible, guys?
Yeah, Rakesh, you're audible. Yes, I remember that.
Great. Okay. And so like few more things that we have discussed, like how like why do we need statistical method, right? So it helps us in data driven decisions, right? It helps us in identifying patterns and trends in the data, predict outcomes, that is basically our inferential statistics, right? And again, it helps us in machine learning and artificial intelligence by organizing the data efficiently, right? So these were the things that we have discussed in our previous class, correct? Okay, now let's move ahead. And today it's gonna be, some bit of practical session. I'll be, teaching you how to, you'll have a data set, a CSV file, right? And how can you use that file in your Jupyter notebook or any IDE that you guys use, right? And how will you interact with that CSV file? How will you leverage that data set? Try to calculate those uh, the methods that we have learned, the like mean, median, mode, right? These kind of things we are gonna learn today, right? So let's start with the descriptive statistics, right? Uh, so can anyone tell me what we have discussed about descriptive statistics in our last class? Shant, Rakesh? Okay, no one. Cool. I'll tell you. So see, like as we discussed in the last class, descriptive statistics are like we generally use it to summarize and present our data, right? It does not helps us to predict something because that's part of inferential statistics. But again, it's very important to understand the type of the data that we have, right? Because it can tell you a lot about the data in very, in a summarized manner, right? So let's say I want to know about the mean age, mean height of a particular segment, sample, or a population. Descriptive statistics can help me, right? So we have methods here like measures of central tendency. You are aware about the measures of central tendency, like we have discussed about them in brief in our last class. Those were mean, median, and mode, right? And the last thing that we were discussing in our class was the measures of dispersion, right? We'll be focusing on these things in this class, right? So the broadly we divide them in three categories. One is range, that's the very basic one. Second is the variance, and third is the standard deviation, right? Can anyone tell me what is the measures of dispersion here? How they helps us, you know, uh, to check, or what are their importances? We discussed something about spread. Can you like do you remember from anything from our last class? No? So okay, we will discuss about it. Okay, so let's start with the very basic thing again. Measures of central tendency, right? So here in this segment, we will discuss about the mean, median, and mode. Okay, in our session 3, we'll be discussing these three things in detail. Like we will be, calculating them for a very large data set, how they helps us in other calculations, right? And then the second thing here is the measures of dispersion, right? So as I told you, right, these values, the measures of dispersion tells you about the spread of your data, right? We will see what is the spread of the data. Generally, we have three methods in this segment. One is range, other one is variance, and third one is the standard deviation. Okay, let's move to the next part, right? So let's see the descriptive statistics in action. Okay, so let's take one example, right? So suppose we have a scores of 5 students here, right? So the scores are like this: 55, 65, 75, 85, and 95, right? Now, how will you calculate the average, right? Do you know how will you calculate the average? Any random guess?
I think we can add all those score and divided by how many numbers of people or students.
Correct. Yeah. Okay, so same thing is happening here. So here I'm just giving you the brief idea, like what all the descriptive statistics you can calculate for a data set, right? So here we are calculating three things. One is mean, second is range, and third is standard deviation. We'll be, learning all these things, how to calculate them basically. So this is just the overview. Okay. The next thing is this summary describes the data but does not predict anything about future students, right? So, but that will be the part of inferential statistics. Like, let's say we want to predict something using the data, but here in the descriptive statistics, right? As I told you, it helps us in summarizing and presenting, right? So how it helps us in summarizing and presenting? So we have plots like histogram, right? So using these histograms, we can show the distribution of the data set, right? We have box charts that basically helps us to compare the categories in the data set, right? And then we have box plots, to show the spread and outliers, right? I'll tell you what are the outliers, how to, measure the spread and all. Okay. And I'll give you an interactive activity as well. I think I must have given you in the last class, right? I've asked you to identify a data set of your choice and try to calculate all these values, right? But in this class, we will be, calculating range and other methods of dispersion as well. Okay. Now let's, yeah, anyone? Justin, can you mute yourself? Thank you. Yeah. So let's move to the next part. Okay. Yeah. So we have
I
already
think,
discussed about these three things, right?
sorry, Rishabh, sorry to
Yeah.
interrupt you. Actually, in the last class, we were till mean median mode, right?
Yep. Yep. So
We have
it's just
not
a recap
discussed.
of the last class. Yeah.
Oh, okay. Sorry, sorry.
Yeah. Okay. I've asked everyone, like, do you remember about the last class? What was
Yeah,
me?
yeah, I remember till mean median mode, but in today's class, we are going to
Yeah.
read about the
Just a quick
range and
recap.
all,
I'll
right?
just take 5 minutes to finish this.
Yeah, yeah, it's okay. It's
Okay.
okay.
And I'll show you as well, like how to calculate, right?
Okay,
Yeah.
okay.
Okay, so as we remember, we have three measures of central tendency. One is mean, median, and mode, and we have already discussed like how to calculate them. But I'll give you a quick recap, right? How can we calculate them? Okay, but before jumping into that calculation, I just want to tell you why are measures of central tendency important for us, right? So as we already discussed, it helps us in summarizing the data set, right? And let's say if we want to compare different data sets, and we have already taken examples in our last, like let's say we were comparing the height of class 5th and class 10th, right? So that's how we can, compare the different data sets as well. It helps us in decision making and understanding the data distribution. But in the data distribution part, it's not just mean. We have a lot of other things as well, right? How skewed it is, what is the spread, right? So these kind of things we also learn. Okay. So yeah, so here we will see how to calculate the mean, right? So as we all know, mean is nothing but the sum of all the values that we have in our data set and divided by the total number of values in the data set. Okay, you can see the example here. We have these 5 values. What are we doing here? We have added all of those 5 numbers and divided by the total number of elements that we have here. So that's how we are landing it with the average score of 70. Right? So when to use the mean? Can anyone tell me? We have discussed this in the last class. When to use the mean? And it's available on the screen as well. Random guess.
I think to take the average of that just in the statistics
So
manner.
that's the basic fund about it, right? I want to
Yeah.
know when to use the mean. Let's say we have another measure of central tendency, right? Median.
Mm.
So what can be the scenario when mean is not up to the mark?
When the data is repeated, then mean will be not the exact value.
No. So
No.
let me tell you, okay? Mean, okay, so if you see the last part of it, right? Limitations of the mean. Okay, we can use the mean when we have symmetrical data, right? Almost similar range of values, right? If you see the examples that I've taken just above this, values are not, differing that much. Like all are in almost similar range, like 50, 60, 70, 80, 90, right? But if I add a value like 500 there, right? So it's kind of extreme value for this data set, right? So if your data set is having extreme values, right, then your mean will not give you the correct picture of your data. You can see the last line of this PPT, right? So if I just add 500 in the above data set, your mean will change to 141.67, right? So now with this value, can anyone tell me like what kind of data I have, right? I think most of you will tell me like it'll be close to 141, correct? Maybe the least value that you can have 120, 110, right? But is this the value that we are having in our data set? No, right? Because of this extreme value, our data set is getting impacted, and the ultimate mean that we are calculating is a very big number, right? So here the extreme values will not be able to calculate the correct, depict the picture of a correct data set, right? So generally what happens, in statistics, right? People will give you a mean value and measures of dispersion, right? So measures of dispersion will tell you, okay, how is the spread of your data set, right? But if you are having a wrong mean value because of the outlier, it'll be very difficult to judge the correct values. Okay, so all of you understood when cannot be used the mean?
Yeah,
Okay,
understood that.
great, cool. Let's move to the next part. So we discussed about median as well, right? So median is nothing but the middle value of an order data set. All of you remember?
Yes,
Yes, right. So, and we discussed two things, right? When we have odd number of values and even number of values, because in case of odd number, you'll be able to find the middle value of that data set, right? But if it is even, right, you will be having two values. So what we do, we basically take the average of those two numbers. So here in the even example, we have values 70 and 80. So we are taking the average of those two numbers, and the median that we are getting is 75. Okay, all of you are aligned?
yeah, yes, yes,
Great. Okay, yeah. So similarly, like as we discussed in our mean part, right? When to use the mean, right? Here we will discuss about when to use the median, right? So the challenge that we were facing in the last segment was we were having an outlier, the extreme value, and because of that, we were getting the wrong idea about our data set, right? So in that case, right, what you can do, you can calculate a median value. So it's not, the beauty of the median is it's not impacted by the outliers, because here what we do, we arrange the numbers in the order, right? And then we try to find out the middle value. So that's how you'll not be, your data set or your measure of central tendency will not be impacted by the outlier. Okay, so the best example in this case is income distribution, right? Even if you talk about a particular company, you'll be having very varying salaries, right? CEO, the CXOs, right, will be earning a lot of money, right? And if you try to, calculate the average of the salary for that company using the extreme outliers, right, including the salary of CXOs, you'll be, land up with a very wrong number. According to that, your employees are earning very high salary, correct? Similarly, if you include the example of, your test scores only, right? So let's say you have five very brilliant students in the class, right, who always scores more than 99%, right? But rest of you always scores below 85, right? If you include them, if you include their scores with your data set and take the average, you will end up with a very large number, a large average compared to your own scores, right? So that will give you the wrong picture about the class, right? So that's why median is important in this case. Okay. Again, there are some limitations of the median, right? So it does not use all data points. So that's one of the problem, right? Because we are also ignoring the extreme values that can be important in some cases, right? And it just focuses on the middle values, right? So let's say we have trailing one at the start, right? One, and then you are starting having some values, okay? Like numbers like 50, 60, 70, 80. So your median, the ultimate median will get impacted by these kind of things as well. Okay. So it's not a precise solution, but better than mean. Okay. Any questions so far?
No.
Okay, great. Let's move to the next slide. Okay. The next thing was mode. All of you remember we discussed about the mode, what it is, right? It's the most frequent value in your data set. Okay. So we discussed about three types of mode, right? Unimodal, bimodal, and multimodal. So if you see the first example, we have values like 2, 3, 4, 4, 5, 6, 7. In this case, we only have one frequent number that is coming, that is 4. Okay. Bimodal data set, here we have 1, 1, 2, 2, 3, 4, 4, 5, 6. So if you see here, we have two frequent values that are coming here in this example, that are 2 and 4. Okay. In case of multi-model, you'll be having multiple values like 1, 2, 4, 1, 2, 3 here. Okay. And then we have discussed about like when to use the mode when we were having categorical data in our data set. Okay. Any question? Any confusion here?
No.
Okay. Cool. Okay. Now let's move to the next part. Okay. So it's the overview of, choosing the right measure of central tendency, right? You can see here the scenario is data is symmetrical. We don't have any outliers, right? So the best measure to use is mean. Okay. Correct. Cool. Okay, if your data has extreme outliers, then what is the suitable measure of standard tendency for you? It is median, as we discussed, right? Because it's not affected by your extreme outliers, right? And if the data is categorical, like favorite color, most sold product, then we'll go ahead with the mode. Okay, mean and median don't work with the categories as we discussed in our last class, right? Because not numerical value. Okay, need to find the most common value. Again, mode will help you here. Okay, shows which value appears most frequently. Let's say if you want to see, you have a test scores from your class. Now you want to see what score was the most frequent one. So most of the students are getting 50 out of 100, let's say, right? So that can tell you. Any questions so far till here? We'll be moving to the next section. That is very important.
No question for me.
Okay.
Please.
Mhm. Okay, I guess no question. Cool. Let's move to the next class or next segment. Okay. Yeah. So visualizing central tendency. Okay. So it's a very important thing, right? When you visualize the histogram of box plot, right? So if your data set is symmetrical, right? I mean, if your distribution is symmetrical, you will be having mean, mode, and median on a single line, right? All three things will be having the same value. But if it is right skewed, your mean will be greater than the median and median will be greater than the mode. Okay. Similarly, if it is left skewed, your mode will shift to the higher side, then median and then mean. So this is how we identify the skewed in our distribution. Okay. We will be taking example of these all these three distributions in our next classes, right? When we discuss all these things in very detail. Okay. Okay. So I think we ended our last session here. We were, planning to discuss about the measures of dispersion, right? We got the brief idea about the range, but we wanted to discuss about variance and standard deviation. But before that, let's have a practical session and let's see how we can calculate it for our actual data sets. All the mean, median, and mode kind of thing, right? All of you are ready? Okay. Just give me a second. Let me open my Jupyter notebook. Is it visible to all of you? Jupyter notebook?
Yes, it is visible.
Okay, great. Okay. So how many of you are aware about Pandas library? Have you used it?
Yeah, I've used it in my project, Pandas.
Okay. Great. So we'll be using this library a lot in your, machine learning classes. It generally helps us to, play with your data. Okay. So we import this library like this, import pandas. Okay. So I'm like rename this as PD just to, help me. I don't want to write this pandas again and again. Okay. So let's read your data set that we have here. Okay. So to read the data set, we will be reading a CSV file. So the command is pd.read_CSV. Okay. So we will, go into the downloads section. And then we have archive folder there. The file name is student score CSV. Okay. So now the data from this file is in our df object. Okay. So if you see, we have this df.head. So using this head command, we can see the data set. Okay. So it'll give you the top 5 rows from the data set. Okay. So what all we have here? We have first name, last name, email, gender, part-time job, absence days, extracurricular activities, false true. Okay. So these are the data points that we have. Okay, now let's pick any column from here and try to calculate the mean of this. Okay, so we have this math score column. Okay, we generally, so there are two ways to select a column from a data set. Okay, first is this way. You can just basically put it inside the brackets and mention the name. Okay, and then you can simply type the command dot mean. So now the mean of your math score is 83.452. Okay. Similarly, you can calculate median as well. Any question about this? Any confusion? No? Right. So it's a very simple command, right? You can just simply write dot median. It'll give you the median. Okay. So what are these two values telling me? Can anyone tell me based on our last discussion that we had, like in the previous slides? The mean is 83.452 and the median is 87. Any random guesses about the data set, about the scores? Okay. See, so your mean is quite close to the median. If you see here, right? It means we don't have any extreme values here. Understood? Okay. So there's one more beautiful command, right? That basically gives you the complete picture of that column. Okay. Let me show you. So we have this command dot describe. So it basically describes all the properties about that column. Okay. So now if you see here, the total number of scores that we had was 2000. Okay. The mean of the data set was 83.452. We got everything from that just one single command that describe, right? Then we have the standard deviation that is basically 13.224. Okay, we will talk about this in the next slides. Okay, the minimum value that was there in this data set was 40. And these are the percentile values. We'll be, studying about the percentile, how percentile works, right? So the 25th percentile was 77. Median. So your 50th percentile is nothing but your median. Okay. So that was 87 and the 75th percentile is 93 and the max value that we had here is 100. Okay. So if you like run this describe command on any column, that can tell you about the extreme values. So let's say if your column is having values like 500, so it will come here. That's how you can analyze, okay, why my mean is very high compared to my median. Okay, these things you can check using these commands. Any question or confusion? Okay, great. Good. So now we have this column career aspiration here. Okay. So let's see about this column career aspiration. Okay, first. So this is not a numerical column, right? So what operation we can perform for this column? Can anyone tell me? Go ahead, go ahead. Anyone? Any random guess? Okay, I guess no one. Okay, cool. So I'll just run this command. I know it will not work. I just want to show you what kind of error we will get here. Okay. It's taking time. We'll end up with an error.
But it is a string value, right? How
Yeah,
can
yeah. So
we
that's what
calculate that?
that's what I was expecting from you guys to tell me that we cannot calculate any numerical statistic or numerical measure of standard tendency for a string value, right? Okay, so we got this error because it's a string value. We cannot calculate any numerical thing, right? So what is the optimal mode of central tendency here? Anyone? We just read about them. Okay, so it was mode, if you remember, right? So the most frequent career aspiration that students want to have is software engineer, right?
But
But
there is no column of software engineer. There is only lawyer, doctor, government officer,
no,
and
these are just
architect.
five. These are just the top five rows from your data
Okay,
set.
okay, okay.
Okay, the size of your data set is 2000 rows. Let me show you. Okay, if you want to see the size of your data set, you can just simply type the command df.shape. So you have the values from the 2000 students. Okay.
Got it. I thought, okay, it's only five things that I could
No, no, no.
see here.
Yeah. Now let's see one more thing. Okay, I told you about one command, right? df.describe, right? It's a very beautiful command. Even it works for categorical data as well. Okay, we simply type df.describe. Okay, so it'll give you the count, right? It'll give you the unique, how many unique values are there in that column in the career aspiration. So it was total 17, right? So the topmost, the mode was software engineer. Okay, and the frequency was 315. Okay, so we have one more command that basically will tell you about each and every category in this column. Okay, let's see that as well. So that is the value counts. Okay, so if you see the value count, so I just ran this command just to prove this as frequency is right for software engineer. Okay, so if you see again software engineer, we have the 315 count. Okay, the next best value was the business owner. One second, I think my battery is going out. Let me put it on charge. Please give me 1 second. Meanwhile, you can type a question or you can tell me if you have any doubt. Anyone with any doubt?
No, no doubt for me at least.
Okay, so all of you understood how to play with your data set, how to calculate all these measures of standard tendency in your Python notebook.
Yes.
I'm assuming yes. Okay, great. Okay, I can spend a few more time on this CSV file if you guys want me to do it. We have a few more columns here. We can play with them. If you want to study, next part of it, then we can go ahead. If you want me to perform any operation on top of this data set, you can tell me now. Anyone?
If there is like more commands, then you can perform, right?
Yeah, there are a ton of commands. Okay, so let's plot some graphs. Okay, so we have this library that is Seaborn, right? So it basically helps us, to plot the, like we talked about summarizing the data set and presenting it, right? Summarizing we have already done. Now let's present it. Okay, so we'll be using the SNS Seaborn library to do this. Okay, so let's start with the histogram. Okay, we already have this carrier aspiration here. We will, start with the count plot. Is this? Okay, so I'll tell you one trick as well. So let's say if you want to see what will go inside this function, right? Whenever we are using, any library in Jupyter Notebook, especially, right? You can have this kind of pop up if you press Shift Tab together. Just write this bracket and press Shift and Tab. You will get this kind of pop-up. It'll basically tell you what kind of arguments it takes, right? This function. Okay. So here we'll have to pass the data set, X and Y values, hue if you have, right? You can just open this library and read about all these arguments here, right? And if you go down, most of the time they write examples as well, right? So in this case, they have not written any example, but we can simply print it. Okay. So we will, pass this column inside this. Okay, there's an error. Could not convert string to float. Okay, yeah. So the problem is the count plot works on the integer values, but it'll basically give you the count of your class, right? So if we convert this carrier expression into numerical values, right, we can have the representation of each and every class with a number, right? Then it can basically give you the count of that, right? So any question? Anyone was asking something? Okay. Okay. So first, let's start with the absence phase. That this is the easy one that we can take. I don't want to, waste your time. Yeah. So we don't have much classes here. Absence days, very nice. Okay. Let's try with gender. Okay, gender we don't have value. Okay, let's plot the histogram first. Okay. Similarly, as I told you, what you have to do, you can press Shift Enter and check what all values goes inside this, right? But we will not do that. We will simply type the column name that we have here is the math score. Okay. So this is how it will look like, right? So if you see your curve is looking like this, right? This is going like this. So anyone can tell me like what is the mode here? So we learned something, right? How to visualize our skewness in our histogram or a distribution. Or can anyone tell me what is the mode here using this graph? Okay. So here
I
if
think
you
it's
see
between 80 and 90, right?
this the topmost peak, right?
Yeah, definitely.
Great. Yeah. Correct. Very nice. Right. So this is our, mode of this data set. So here, what is this count representing? It's basically the frequency of that score, right? So if you see, we have already calculated the mean, median, and mean, median, and mode of the data set, right? So mean was 83.452, median was 87. And mode, if you see, if we have not calculated mode for this, we can calculate mode as well. Okay. So mode will be somewhere around 99. That is fishy, but okay. Okay. Maybe some because of some issue it's we are getting 99, but it should be somewhere here. Okay, here according to the graph, right? So basically that's how we represent our data set using the graphs. Okay, now let's plot one more thing. We'll just plot bar plot now. Box plot basically. We'll add a column here. Okay, we'll be having a box plot. Okay, and we'll simply run this plot. Okay, so what this box plot is telling you, right? So it basically gives you the picture of your data set, right? So you have like very few values here, like below this range, right? And most of the data is basically lies in this segment between like somewhere 75 to 95, right? So this is so this basically helps us, to find out the extreme values in our data set. So here in this case, the maximum is 100, and we have few values that is basically below 55, right? So if you see, I'll teach you like one good thing, right? So it's just playing with the data. Let's say if you wanna check like how many values are there below that particular segment. Okay, so you can just simply write less than 55, and then you can just print the shape of it. So we have only 83 values that are below 55. Okay, any question here? How do any confusion with the command? No. Good. Okay, so let's go ahead. We have few more plots, but that maybe difficult. We can study those plots in your upcoming machine learning classes, right? We use them when we try to analyze the data set in detail, right? We have Euler plot, we have heat maps, right? That basically tells you about the correlation and all. Pair plot, a lot of kind of plot, but all these plots are possible using this particular library, Seaborn. You'll not be getting very good visualizations, but this can work for an analysis, right? If you want very beautiful visualizations, you can use Plotly library. Okay, this is the spelling of that library. You can use Plotly for the beautiful and interactive plots, right? Because this plot is not interactive, just a static version of it. Okay, if even if I hover, you'll not be able to see anything, but using a Plotly library, you will be able to see the values here. Okay, any question? Anything else that you want to learn on this notebook? Okay, great.
Like
That's good.
Plotly library is better than this one you're talking.
Yes, because it'll give you the interactive plots, and the visualizations are quite beautiful, right? See, it depends when you are presenting it to a business, right? You may need some interactive plots that you can present, change in front of them, right? But here it's a static thing. Let's say I want to just focus on this particular area. I can just simply, here it's not possible. I can simply crop this. I can make a circle or box out of it, and it will show you that particular segment.
Like on the Plotly, if I hover between this 40 to 50, then I can check how many peoples are
Yeah.
there in between 50 and 40. Right.
Yes. Yeah, let me show you some examples if it is available directly. Okay. So yeah, if you see here, this is the graph, right? If I want to do something like this, I want to see this particular section, I can zoom in. Okay. Even if I go there, it'll tell me the values, what kind of values I have. This is the beauty of Plotly library. Okay. You can have this kind of graphs, the interactive graphs. You can just focus on this segment, you know. See, now it's zoomed in, right? It's and even like if you zoom in, all these particular segments is also like changing with the graph, right? So that's why the Plotly library is better for the visualization part of it. Yeah. Okay. So for homework, what you can do, you can just simply download this data set from somewhere. What I can do, I can share the link with all of you guys, right? Uh, it's available on Kaggle. You just simply search for student scores Kaggle. You'll get it. Are you guys on Kaggle? So the
Yes,
website
I
name.
used it for the like collecting the data set for my project.
Okay. So on the Kaggle library, you will I can paste the link. Wait. Just give me a second. Student scores data.
If you could paste it over the WhatsApp, it will be helpful for us.
I'm not on the WhatsApp group. I can paste in the Zoom chat. You can copy it from there.
Yeah, yeah. Okay, okay, we're done.
Okay. This is not the- ah, okay. So this is your homework, everyone. Download this data set and play with it. Okay. Try to, show me as many visualizations as possible. Okay. And try to calculate all the measures that we have learned in this class. Right. And we'll be learning few more now that, that's again our homework. Right. Okay. Let's move to the next part. That is very important. Okay. Yeah. Okay. So we have learned about the measures of central tendency, right? So it basically tells you about the center of the data. But measures of dispersion describe how spread out the data values are, right? They helps us understand the variability in the data set, right? How varied our data set is, right? So let's say that we are saying the average is 60, but okay, what kind of values I have in my data set? If you know that this value measures of dispersion, then you can, imagine it or calculate it, right? It can give you the picture, okay, what kind of values are there. So if all values in the data set are close to mean, it means your dispersion is low. It means your data set is having very less variability, right? If the values are widely spread, right, you have values like the scores that we saw just now, right? The minimum that was around 40, 45, and the maximum was around 100, and the mean was around something 80, right? So it means your data set is having high variability, so your measure of dispersion will be high. Okay, so why are measures of dispersion important? As we discussed, it helps us understanding the data variability part of it. Okay, two data sets can have the same mean but different spreads. Okay, that's also possible. Okay, so just on the basis of mean, we cannot decide that the two data sets that we are having are similar. Okay, so if I'm telling you the height of two classes, the average height of the two classes both were 5 feet, but if the measures of dispersion is very different, right, then these two data sets are not similar, right? So we cannot decide something just based on the measure of central tendency. So that's why this measure of dispersion is very helpful for us. Okay, and then it basically helps us in identifying stability and risk in the data set. Okay, so you can take example of stock in, right? If it is having very high dispersion, it's very riskier than the low dispersion stock. Okay, because it does not move much. Okay, useful in comparing data sets, we have already taken the example, right? If we talk about average salary, right, of two companies, So if the dispersion measure of dispersion is very less in a company, it means all of the employees are almost equally paid, right? But if it is very high, it means the data variability is very high. So some of them may be getting very less salary and some of them may be getting very high salary as well. Okay, so based on that, you can decide which company is good or which company is bad compared according to the salary. But in general, you will be having very high variability everywhere. Okay, any questions so far? I guess no. Okay, cool. We have already discussed about the range in our last class, right? How to calculate the range. It's the very simple measure of dispersion and nobody uses it. Okay, just to put it in your mind that there's a measure that is range, right? I want to tell you about it. It's basically the difference between the maximum value and the minimum value, right? And it's very difficult to judge about the variability of your data set with just this range value. Okay, let's say if I'm telling you your range is 40, what can you interpret from these five values, right? Obviously, like if I'm giving the max value, like you can tell what is a sorry, if I'm giving you the minimum value, you can tell me the max of a data set. But with the center value, it'll be difficult to say something. Okay, just a quick measure of variability. Okay, so we generally don't use it, and it's very sensitive to the outliers, right? Let's say if your maximum value is very high, very high, right? So let's say instead of 50, you have 500 here, right? Your range will be 400, 500 minus 10 will be 490. So it's not making any sense, right? It's not helping you at all. Okay. And again, it does not show the distribution of values within the range. So it's just plain simple calculation that we generally don't use anywhere in data science. Okay. Let's come to the most important measure of dispersion, that is variance. Okay. It's nothing but the average square distance from the mean. Okay. So you can see the formula here. Okay. We represent variance with the sigma square. Okay, we have all like I think we have everyone studied about this in our elementary schools, right? It's the same thing. Okay, how we calculate it? So it's the summation of your mean, sorry, the value minus mean square divided by the total number of elements that we have. Here xi is representing each data point, x bar is representing the mean of your data set, and n is the total number of data points. So we will see this step by step. Okay, so let's say we have these five values in our data set: 5, 10, 15, 20, and 25. Okay, so let's find the mean of this data set first. We all know how to calculate the mean, right? It's the total number of the sum of all the values and divided by the total number of data points that we have. So for this data set, the mean that is coming up, it is 15. Okay, now the next step is, right, we will calculate the average. Now we'll calculate the squared distance from the mean first, right? So first data point was 5, our mean was 15. So 5 minus 15 square was this, it is 100. Similarly, we will calculate it for all the data points. Okay, so you're coming in with 100, 25, 0, 25, 100. Okay, now what we will do, we will sum all of them and divide by the total number of data points. Okay, so the final variance that is coming for us, it is 50. Okay, any questions so far? Anyone? Okay. Except Prashant, anyone? Good. No one is there. Yeah. So when can we use the variance, right? So as I told you, we have one more, measure of dispersion, right? But that was not that helpful, right? Because it was not giving us about the precise measure of variability, right? But if you need a precise measure of a variability, this is the best method. Okay, you can calculate the variance. It'll help you to tell about the variability of a data set, right? So again, we can take example of finance, right? If higher variance is there, it means it's a riskier investment. Your data spread will be very high. Okay, but based on the range, you cannot decide that because it could be impacted by the outliers. Okay, now there's another thing, limitations of variance, right? So units are square here. If data is in meters, right? Variance is in square meters. So it's little difficult to interpret, okay, because of the bigger values here. When you start playing with your data sets, right, you'll get to know how it works, right? So mathematically, any doubt here, how to calculate the variance? Okay, I guess no one. Yeah. So let's move to the next section. That is the standard deviation. And it's the most common measure of dispersion, right? So it's the very simple thing. It's basically the square root of variance that we just calculated. Okay. It measures basically how much data points typically deviate from the mean. Okay. So the calculation is looking like this. We have already calculated the inner part of it. We are just taking the square root of the variance that we have just calculated. Okay. So why take the square root? The variance wasn't, in square units, which is not intuitive, that as I mentioned, the limitations that we discussed about, right? So taking the square root brings it back to the original value of the data, right? The same unit that we were using, right? So now if you see, if we take this square root here, the standard deviation that is coming is 7.07. You'll get the bigger picture about it when we will discuss about a normal distribution, right? We have 3 4 types of distribution that we'll be discussing in the class. I'll show you how these things helps you to decide, like to decide what kind of values, what kind of variability is there in your data set, right? So any questions so far? How to calculate standard deviation? I guess no one.
Like if I want to calculate the standard deviation, then I need to first calculate the variance of that,
Correct.
right?
Yeah, you have to first calculate the variance, then basically take the square root of that. It'll become your standard deviation.
Uh, just I need to take the square root of that. That will
Yeah,
be our standard deviation, right?
correct, correct, correct.
Okay, got it.
Okay. Great. So again, when to use the standard deviation? Again, the same thing. If you need accurate and interpretable measure of variability, we will go ahead with the standard deviation. Okay. We use this a lot in the quality control, finance, and research. Okay. So how standard deviation affects your data spread? So if you're having low standard deviation, it means data points are close to the mean, the last variability in your data set, right? If you are having very high standard deviation, vice versa, same thing, data points are spread out, more variability in the data set, right? We can see some example here comparing two data sets. So let's say the data set is this 10, 12, 14, 16, and 18. Okay. So mean of this data set is 14 and the standard deviation, if you calculate the standard deviation of this data set, it will come to this 3.16. Okay. So what this standard deviation is telling you, so your data set is tightly packed around the mean, right? So if you see how far is 10 from 14, it's almost your standard deviation, right? Right? Everything is almost coming in the range of standard deviation, correct? But your standard deviation is very low, right? It's not a very big number. It means your values are quite close to the mean, correct? Similarly, if you see the next data set 5, 10, 15, 20, and 25, your mean is 15, but your standard deviation is very high. It means the values, the other values from the mean are very far. Okay, let's take first example only. If you calculate 14 minus 10, right, it's just 4 units away, right? But if you calculate the same thing in the last example, it is 15 minus 5, that is like 10 units away. Okay, so what it is telling you, your data set is having more spread, high variability. Any doubts?
No, no doubt.
Okay, cool. Okay, let's summarize everything that we have learned. Okay, so we talked about three measures of our measures of dispersion, right? One was range, that is basically nothing but the difference of your maximum and minimum value. Okay. So what it tells us, quick measure of spread, right? Nothing. I mean, it's just a very simple idea about the dispersion of a data set, right? Best use case, basic comparison. As I told you, we generally don't use it, right? Variance formula, we remember, right? Now, like, it basically tells you how far data points are from the mean, right? But in squared units. It helps us in the theoretical analysis, right? But standard deviation, that was basically the square root of a variance, right? So it basically give you the picture, like how typically, how far is your value from the actual mean, right? So it basically, like, it's in the similar units, right? So that you can interpret. That's the beauty of this. Okay, so we generally use this everywhere in analysis, right? In the real world analysis. Okay, so now let's talk about the key takeaways from the session. We learned about dispersions, we learned about range, variance, and standard deviation. Okay, before moving to the next section, anyone is having any doubt?
Like if we take the example as a salary of employees, okay, then
Okay,
how it will change in the basic of range, standard deviation, and another one.
okay. So let's use the same CSV file that we were using. Okay, in the same Jupyter
Okay.
notebook. I'll show you how it works there and how it differs. Okay, let me open that notebook for
Like,
you
is
again.
there any difference between the histogram and the bar graph? What we have seen the histogram, right?
It's same
And
thing.
any same
It's
thing,
the
right?
same thing. Yeah.
Okay.
Okay, we already have this loaded, right? Cool. We will be using math score again. So first, let's calculate the range. Okay. As we know, range is nothing but, first let's calculate the max and min of your math score. Okay. So as I told you, range is nothing but the difference of your maximum and minimum value, right? You remember? Okay. So that's how we calculate max and min of a data set. Okay. Now we just have to, take the difference of these two values. I can take it directly 100 minus 40, but I just want to show you how this works. Okay, if you want to write code like this. Okay, so this will give you the value of your range. So your range is 60. Okay, so now let's calculate the variance of your data set. We'll just take this column again. And the formula is very direct. You can simply write here. You don't have to write that mathematical formula in pandas. It's already implemented in the function, that is variance. Okay, so your variance is coming out as 174. Okay, see, all the scores were in the range of hundreds, right? But your variance is coming as 174. The reason is it's a squared unit, right? So that's why we generally use standard deviation. So if we calculate the standard deviation of your column, right? Let's calculate that. Okay. So again, simple formulas we have here. It's represented by STD. Okay. So it is what, 13, right? So if we take mean of your math column, right? So if you see, like here, the standard deviation is not that big, right? Or can be like, it's a big number according to me, but for you it should not be that big, because like, we are analyzing a number here, right? It's just, it can be here and there because all the students are not same, correct? It depends on the use case to use case. If we are comparing salary, it'll be much bigger than this, right? Because for a score the range is limited, but in case of a salary you will be having a lot of variability, right? Someone maybe entry level person, let's say, is earning 30,000 per month, but a CXO level is earning somewhere around 4 lakhs or 5 lakhs per month, right? So the variability is very high, right? So that in that case, you will be having a very large standard deviation. Okay. So any questions so far? How to calculate this using pandas? Any question about variance and standard deviation?
No, got it. If we
Okay.
take for the salary also, like the range will be like differ a lot.
Yeah, it will differ a
6,000
lot.
changes in
That's
the
what I was trying
standard
to tell you.
deviation, right?
You will be having a very high standard deviation in that case. But here in this case, our scores are not varying that much, right? But let's say if we take example of any difficult subject, right, where we can see, okay, I can see,
You would take for the English, I think it will be like same for almost.
okay, let's take English. Yeah, okay, let's calculate ranges. But have you like noticed one thing? Our range is giving the poorest possible measure for us, right? With 60, you cannot decide, right? If you're standing at 100, right, and I'm giving you range 60, right? And I'm not telling you 100 is max, right? It's very difficult to decide like what is the spread of a data set, correct? Even if I give you the mean, like mean was 83, and I give you this range, right? So according to you, the maximum value could be 140, right? And that does not even exist in a data set. So range we never use. It's there in the literature. That's why I taught you. Okay. Yeah. So bad news. It's coming. It's even better than the last one. So it means your score is not varying that much. And we can see that if using this, we can plot our histogram, right? And we can see the variability. It's almost in, right? So in the other case, it was even worse. Okay. Any questions so far? Can we move to the next segment?
Yes, we can move. Right.
Okay.
Actually, I'm using my own data set that I have used for my database,
Mm-hmm.
school, like college product.
Okay.
Their like salary of the differ from the peon salary to the CEO salary. The range
We
between that will differ a lot.
correct. Correct. As I told you, right? For entry level jobs, for blue collar jobs, right? If you're comparing white collar job with the blue collar job, you'll be getting a lot of standard deviation, right? So better divide them, right? So when we analyze the data, we divide them in the segments. Instead of calculating it for all the segments, we calculate it segment wise, right? So that's how you get the better idea. So for maybe blue collar jobs, you can just calculate it for that segment. For white collar jobs, you can calculate for that segment. So that's how you can do that. Okay. So now
Yes,
let's
yes.
move to the next part. So that is the inferential statistics, right? Okay. So we will not discuss this in detail. We'll be discussing it in brief here because in the upcoming sessions, we'll be playing with the data a lot, right? Okay, so what is inferential statistics? We discussed about it. Can anyone tell me like what it is? It's available on screen as well. If you can just read it, I will not allow.
Like basically for the generalization and the calculation, like what we have done till now.
Yeah. So
We basically,
it basically helps us in predicting, concluding, and generalizing about a population based on a sample data. Right? We discussed
we
about
are not
population.
predicting till yet, right?
Sorry.
We are not predicting till yet.
Huh,
Like,
because we were using the differential statistics, right? We were studying about the differential statistics, right? But if you jump into the differential statistics part of it, right? Like I have mentioned this in the start only, differential statistics basically, descriptive statistics basically help you to summarize and present the data set, right? But if you want to predict something about it, right, then you will be using the inferential part of it, correct?
yeah,
Okay.
yeah.
So what are the key features of inferential statistics? Right? It helps us, draw conclusions beyond the data. Okay. uses sampling methods to make inferences. We'll talk about it. What are those sampling methods? But I'm assuming you guys are aware about population and sample. We have already discussed in our last class. Okay. Common techniques you include hypothesis testing and confidence intervals. So it basically, helps us write the sample set that we have taken out of a population is relevant for that population or not. Right? It's able to, represent the whole population. We are able to, so let's say if I'm testing something, right? Is that sample set enough or not? So a lot of use case I can, perform on a small data set. So let's say I want to test a medicine, okay, but I cannot go and check, right? Everyone in the world, right? It can work for them or not. So what I'll do, I'll take a sample set, right? That basically covers all type of people in the world, right? So all type of people can be like you are, launching a diabetic medicine for a diabetic person, right? So you will take a sample set, right? Type 1 diabetic, type 2 diabetic, or what kind of level of diabetes they have, right? So all sort of person, and then you will test on them. And there are tests like you can, use to check if that data set is relevant for your use case or not. Okay. So what are the key difference between the descriptive statistic and inferential statistic, right? So as I mentioned earlier, descriptive statistics basically helps you to summarize the past data, right? It uses the whole population. But in case of inferential statistics, we will not be using the whole population. We will be taking the sample because in real life, using whole population is not possible, right? We perform descriptive statistics on a limited data set that we have in our files, right? But we use inferential statistics when we are talking about the very large population, right? Okay, so here no uncertainty involved, but in case of your inferential statistics, it's highly uncertain, right?
If like I could say that if like for the prediction, the sample should be accurate, there should be no bias, right? That's the
Yeah,
basic point of that.
yeah.
Okay.
We'll be like reading everything in detail. Don't worry. Okay, but no guess is quite correct. Okay, so let's take an example scenario here. Okay, so I just want to give you the idea, right? When your inferential statistics come in the picture. Okay, so the example here is, or you can call it as a scenario. A company wants to know the average salary of all employees. Instead of serving all 10,000 employees, they collect data from 500 employees and use inferential statistics to estimate the average salary for the whole company. Right. So what we have done here, instead of collecting the information from all 10,000 employees, that is a tedious job. Okay, and you can say because here we are talking about a very small number, it could be 10 crore or 10 million, right? So that data collection is quite tedious, right? So we can perform, statistical tests using just the data of 500 employees. But condition apply is this 500 employees data set should be randomly sampled, right? We'll talk about what is random sampling, right? But it should not be biased. We talked about in our last class, right? What kind of biased data set we have. Okay. So now what are the types of inferential statistics, right? We have estimation, that is basically point estimation and interval estimation. So in case of point estimation, we predict a single value. Let's say, for example, the average salary of all the employees. In this case, it is $50,000. Okay. In case of interval estimation, we provides a range, right? So range could be like the average salary is between 48,000 and 52,000, and we give confidence as well. So generally it is like confidence interval. Okay. Then we have this hypothesis testing, right? Test assumptions about a population using a sample. Okay. So basically we, as I told you, I've given you a very nice example. We am planning to launch a medicine or a drug, right, for a diabetic person. So is my samples able to, represent that whole population or not, right? Will it work for the complete population or not, right? So we can take this example. Does a new drug improve patient recovery significantly or not? This is a test, right? And I'll try to prove it using the hypothesis testing. We'll be reading about it in detail in our upcoming lectures. Okay. Now, the second thing is the probability distributions, right? We must remember, like I was telling you about the distribution, right? How these measures of dispersion that we just calculated, how they will help us to, analyze these distributions here, right? So we generally use them to model the real world situations. You saw that graph, right? When we were checking the math score and English score, they were not the perfect bell curves, right? So they basically tells us about the distribution that we have. Okay. Let's not do that interactive activity. We are running out of time. Okay. So here, let's compare descriptive and inferential statistics again. Okay. So the aspect, the purpose. Okay. We basically summarize the data set using descriptive statistics. We make predictions using inferential. It's the same thing that we have discussed, right? Discussed, right? Again, the what is the next aspect, right? That is scope. So in like scope of descriptive statistic is focuses on the observed data set that is visible to you, right? That is available in you, like for you as a file. But inferential statistics, it generalize beyond your observed data set, right? Because you will be having a sample only, but you will try to predict it for your whole population. Okay. And example, right? Average score of a class. Okay. But here in case of inferential statistics, predicting national exam results for a small sample. Okay. So this is kind of example, right? Here we are talking about a particular segment that is class as a very small set, right? But if you're talking about a score of a national exam, it's a very large population. It's just a brief thing that I'm telling you. We will be reading everything in detail, like we have read about the descriptive statistics, right? Mean, median, mode, variance, standard deviation, right? Okay. Now the session summary and key takeaways. This is the last part, right? So in this session, we talked about descriptive statistics, right? It helps us in summarizing and organizing the data set, but do not make any predictions. Okay. Inferential statistics make predictions and draw conclusions based on the sample, right? As I told you, we'll not be having the overall population, but we'll be using a sample out of it, right? Both methods are very important and crucial for data science and machine learning. You saw already everything on the notebook, right? How we were calculating all these things and these features, these calculations really help us, right? I can give you a very nice example when these mean, median are and even mode are very useful. So let's say in your data set, you are having some missing values, right? And you want to impute those values. So what kind of quick assumptions you can take? You can fill those values. If it is numerical, you can fill it using the mean, right? You can fill it using the median if you are having extreme values in your data set. If it is a categorical value, like where you don't have numerical data, it's kind of a classes, right? You can use mode to fill those missing values, right? So every statistic is having some role in data science and machine learning. Okay. Now the homework is find a data set and calculate descriptive statistics that we have just calculated, right? Mean, median, mode, range, and two other things as well, variance and standard deviation. Okay, like we have done in the Jupyter node. Okay, and try to find out a real world example where inferential statistics can be used. Okay, I know we have not studied anything about inferential statistics. I have just given you about idea about what it is, right? We'll be discussing about it in our next session in detail. Okay, any questions so far?
No, there's no questions for that.
Okay, anyone else except Prashant? I guess no one. Then we can end the session. Thank you very much for your time. Have a nice evening.
Rishi, I have one question, but not
Yeah, sure.
regarding this all what we have told and what we have discussed in the session.
Mm-hmm.
Like, what do you feel when you like invite all those people and they've not joined? What we saw today, like, what are like personal feeling about this?
It's okay,
If you
man.
could tell, there is no, you can skip that.
No, it's okay. I mean, see, it's all it's not a bad question, right? See, I'm doing my job here, right? Even when you join some company or let's say you're working as a teacher, right? So at the end of the day, you have to do your work. It doesn't matter, right? If people are joining or not, or because you guys were there, right? I have to teach you. I want to teach you. I want to share my knowledge. So it's good for me. I like that. I want
Like,
all of you to learn
why
everything. Even
I like asked you this question? Actually, my father is a teacher. Then I can visualize that when I was in the middle school, then we were not listening to the teachers, and what could they feel? That's why I have asked this question. Like nothing personal about that.
it's okay, man. No problem.
Okay, like
Okay.
you are a good teacher, bro. I could say that. Actually, I'm in eighth sem, right? I just
Okay.
want to like learn more and more thing about what could be like helpful for my placement and all.
Yeah.
And it was there, statistics was there in my in the curriculum, but I couldn't understand this much what I have understood in this last two season. I'll be really thankful for that for you.
Great. Thank you very much, Prashant.
Okay, thank you, Rishabh.
Okay. Thanks, everyone. Have a nice evening. Bye bye.